everyone! Welcome back to DepEd TV. I am Miss DJ, your study buddy in math, and with a joyful heart and an empowered mind and spirit, learn along with me and let's be math galing! So now, bring out your pen and your self-learning module as we once again demystify sets as an application to the art of solving word problems. In today's discussion, we will be dealing with more challenging problems. To review us on the steps that we need to follow in solving word problems involving sets through a Venn diagram, let us have our friend Ben.
Hi Teacher DJ! Hi kids! I'm Ben, the Venn diagram. Remember the steps I've shared last time? No? Don't worry. We'll run you through them once again. Step 1. Determine what is given and what is asked. Step 2. Illustrate using the Venn diagram. Step 3. Determine what set operations are to be used. Step 4. Using the operations identified in the previous step. And last step, answer the questions asked.
Thank you for that, Ben. Now, here's an example. In a class, 85 students play football, 72 students play baseball, and 43 play tennis. 44 students play both football and baseball, 15 play both baseball and tennis, while 25 students play both football and tennis. 4 students play all 3 sports, and it is known that each kid in this class play at least one of these sports. Now, find the total number of students in the class. In solving problems of this kind, we need to list the given piece by piece so we can fill it in aptly and completely in our diagram. Ben, can you help me identify the cardinality of the sets of football, baseball, and tennis players?
Sure, Teacher DJ. I noticed that if we let set F represent the football players, set T represent the tennis players, and set B represent the baseball players, we will have the following cardinal numbers for the given sets. N of F is 85, which represents students from the class who are football players. N of B is 72, since that is the number of baseball players in this class. N of T is 43, since there are 43 tennis players from this group of students.
Are these the only ones provided in the problem, Ben?
No, Teacher DJ. We still have 4 different sets whose cardinality has not been picked out.
Yes, since we're also required to identify subsets of these 3 sets.
The next thing to do is find the cardinality of each of the recognizable intersections. Right, teacher?
Exactly. We need to know the cardinality of the different set intersection marked in this diagram.
44 students are playing football and baseball, so this must be the intersection of sets F and B. 15 students are playing baseball and tennis, so this shall represent the intersection of sets B and T. We also know that 25 play football and tennis. These shall be regarded as the intersection of sets F and T. What else? Am I missing out something, Teacher DJ?
Well, you also have to account for the cardinality of the set represented by the region found in the innermost part of the diagram, where all 3 circles intersect. The last given points us to what is the cardinal number for this set. Therefore, N of F intersection B intersection T is equal to 4. Also, as hinted in the Venn diagram, there are no elements found outside the three circles because each member of this class is in at least one of these sports. In this step, we also need to identify what is asked in the problem. Ben, please tell us what is asked in the problem.
Sure, Teacher DJ. These are the questions that you must answer. First, how many students are there in the said class? All in all.
This is where we do the second step. Let me emphasize that in our diagram, the union of sets F, B, and T must be regarded as the universal set because as pointed out earlier, each member of this class is a player of at least one of these three sports. The main thing we are going to do here is to plug in the values we have identified in the first step. So primarily, we should enter the cardinality of the subsets into the right region of our Venn diagram. So Ben, based on our technique, where do we start?
We start from the innermost region and eventually after filling out cardinality of sets of the other subset, we'll be moving outward by getting the cardinality of set F minus B or T, set T minus B or F, and set B minus T or F.
Nice job! You were able to pinpoint the needed hint for our grade 7 students so they can work on problem of this type. They must start from the innermost, then go across the intersections and fill out the needed cardinal number in an outward fashion. So, what's left for us to do is to show them how such technique works. Will you please show it to them, Ben?
So let's see what we have. The Venn diagram included three circles with circles labeled as F, B, and T respectively, one for set F, one for set B, and one for set T. As Teacher DJ said, start from the innermost, then enter the other cardinal numbers for the other subset in an outward fashion.
After filling in the center, we proceed to the intersection of a particular paired sets. For example, F and B, then B and T, and F and T. This means that with ease, we can already get the number of elements in the subset where each pair of sets intersect minus the intersection of F, B, and T. Therefore, our Venn diagram will have the following cardinal numbers for the specified subregion of the circles. For the intersection of circles F and B minus the intersection of F, B, and T, the result is 40. On the other hand, given that the cardinality of the intersection of sets F and T is 25, therefore, for the intersection of sets F and T minus the intersection of F, B, and T, the result is 21. While for the intersection of circles B and T minus the intersection of F, B, and T, we got 11. So lastly, what should we fill in next?
Those sets that will form the last group, Teacher DJ. The regions representing those that plays only one sport, either football only, baseball only, or tennis only, must be accounted for last. Thus, the set representing members of the class who play football only has cardinality of 20.
Correct. While the set representing members of the class who play tennis only has a cardinality of 7.
And last but not the least, the set representing members of the class who play baseball only has cardinality of 17.
Now that we have illustrated the Venn diagram, we will now determine which set operations will be used to answer each of the given questions. For the first question, find the universal set which refers to all students in this class. To find the total number of students in the class, simply add the numbers in each region of the Venn diagram. Simply put, get the union of all these sets. So, add 20, 40, 21, and 4, which will give us 85. We continue by adding to 85 the three remaining numbers, 7, 11, and 17. So, we have 85 plus 7 plus 11 plus 17, which will give us a total of 120. Therefore, the answer is 120. There are 120 students in the class. Now, kids, it's our turn to work on some more problems on our own. Let's say goodbye first to our friend. Bye, Ben!
Bye, Teacher DJ!
Our second problem will require us to construct a Venn diagram with 3 linked circles. The problem is, a survey was conducted among 50 people on the ice cream flavor they liked. It was found that 28 liked chocolate, 15 liked mango, and 20 liked strawberry. Furthermore, 11 liked mango and strawberry, 8 liked chocolate and strawberry, and 7 liked chocolate and mango, and 4 liked all the 3 flavors. How many people liked strawberry only? How many people did not like the 3 flavors at all? Step 1. Determine what is given and what is asked. The given are 50 people were surveyed, 28 liked chocolate, 15 liked mango, 20 liked strawberry, 11 liked mango and strawberry, 8 liked chocolate and strawberry, 7 liked chocolate and mango, 4 liked all the 3 flavors. We are asked first to find how many of the students like strawberry only. Second question, how many like neither chocolate, mango, nor strawberry flavors? This is how our Venn diagram should look like. With each subset, we can now enter the cardinal number for each identified region in the 3 circles of our diagram. We apply the same technique, which is to work backwards. We start inputting the cardinality of the intersection of sets C, M, and S, which is equal to 4. And then, following the same procedure we performed in our first example, we will be able to find the cardinality of the second group of sets, which are the regions representing the intersection of exactly 2 of each set. And now, after we have placed those numbers in our Venn diagram, the last thing to do is to find the number of people surveyed who like chocolate only. And this will give us the number 17. Since there are 11 people who also like other flavors. Now, to find the number of people who answered they like mango only, we need to get the difference between 15 and 14, which is equal to 1. And lastly, for the last region representing those who like strawberry only, we subtract 15 from 20, since there are 15 people who like other flavors too. This means its cardinality is 5. Now that our Venn diagram has been constructed, we are now ready to use the set operations to answer all of the questions asked. But before we do that, what is noticeable about this particular diagram? Correct! We are implying with a rectangle enclosing these circles that some elements of the universal set may not be found in the set for C, union M, union S. It figures, right? Because adding all the numbers in the circle will not give us a total of 50. Will you add all the cardinal numbers in the set? Very good! The sum is 41. This implies that the total number of people who like at least one of these flavors, chocolate, mango, and strawberry, is 41. This means also that there are other elements from the set not included within the three sets. So, where do we place the difference of N of U and the N of C union M union S? Okay, it will be written as the complement of C union M union S. How do we find now the cardinality of the set of elements in the diagram who are neither in circle C, nor in circle M, nor in circle S? Correct! We get the complement of the union of sets C, M, and S. And the answer to that is 9. This number of people represents those respondents who dislike all three flavors.
Let us now try to answer the two questions given in our second word problem.
First, how many like strawberry only? The shortest way to find N of S only is to refer to the Venn diagram. You can easily make sense of the numbers inside the circle for S. We interpret this as which elements, or how many in this case, in S are found in the circle S but not in the other two. Very good! The answer to the question in letter A is 5. And for the second question, we go back to our Venn diagram. In letter B, we need to find the number of people who answer none of the above in the survey. These are those who do not like chocolate, mango, or strawberry. How did we represent this shaded region? Good thinking! Earlier, we said this is the difference between the universal and the union of all three sets. And therefore, since the complement of the union of sets C, M, and S has a cardinality of 9, the answer to letter B is 9.
I hope you've already learned the ropes in problem solving using Venn diagram. I'm sure working with all this has made you see the value of perseverance. Math is always teaching us that we may not excel at all the areas in life, but every problem has a solution.
For your assignment, read and study more problems involving set operation in your module.
I'm delighted to be with you today because truly, when we find joy in learning, only then we become math galing! Again, this is Miss DJ. I wish you all a blessed day and I hope to see you again. Kita Kids!